Okay, we're working on section 2.5, complex numbers. A little different than what we're used to seeing, but it's not too terrible as long as we don't let it intimidate us too much. One of the main things that you're going to need to know is we're going to start using imaginary numbers. We're going to use the imaginary unit I. So basically what we need to know is that I is equal to the square root of -1. So for the most part up to this point we've been told that we can't have a negative under a radical, and that's ultimately been true in the past. We'd write no solution. Well, now we're going to learn that there is a solution. It's just in an imaginary category. Alright, so let's look at some examples. If I have, first example, we'll use the square root of -5. Alright. We know that we can reduce radicals. We went through that section already. Now 5 is prime, so the only factors of it are 1 in itself. But that negative that's under there, I can do something about that. Alright, so I'm going to break them apart. I'm going to say that that's the same thing as -1 times 5 under the radical. Alright, -1 times 5 is the same thing as -5. We learned previously that we can break those apart. That's the same thing as the square root of -1 times the square root of 5. Alright, but we just talked about that anytime we see a square root of -1, we said that it is equal to I. So if that's true, that means I can replace this part with one I said it's equal to, right? They're interchangeable. So my solution here would be I square roots of 5. Alright, another example. Let's say we have the square root of -36. Alright, that I can do it. I could do in one step. Let's go ahead and break it apart just so we get a little more practice at it. That's the same thing as -1 times 36. That's the same thing as the square root of -1 times the square root of 36. The square root of 36 is 6. The square root of -1 is I, so I get 6i. Alright, so you get one more. Let's see here. The square root of -24. I'm going to break it apart the same way. That's the same thing as -1, but on 24, I'm not just going to say it's -1 times 24, because if 24 has a factor that is a perfect square, then I can reduce it. And it does. We can multiply 4 times 6 is the same thing as 24. So now I've got the square root of -1 times the square root of 4 times the square root of 6. The square root of 4 is 2. The square root of -1 is I. And that square root of 6, that 6 is just stuck under there. So I've got 2i square roots of 6. Alright, so now we see what imaginary numbers look like. Complex numbers consist of both real and imaginary numbers, and they kind of list them backwards from what we're used to. In most of the stuff that we've been solving, quadratics, linear equations, stuff like that, the constant always goes in the back, like ax squared plus bx plus c equals 0, the constant's on the back end. Or y equals mx plus b, the constant's on the back end. With complex numbers, it's a little bit different. See if I can get this thing to write very good. Alright, so a complex number, the standard form of it is going to look something like a plus b I. Alright, and I always put the little curvy on my I just so it doesn't look like a 1. helps me keep up with it a little bit better. So an example of that might be 3 plus 2i. That would be the standard form of a complex number. All right, so now let's talk about these imaginary numbers a little bit further. So we know that the square root of -1 is I, right? We talked about I represents the square root of -1, which means that if we take that and square it, we're going to get -1, right? So if I is equal to the square root of -1, then I squared would have to be equal to -1. Because if I square both sides over here, that'll cancel out that radical. So we know I equals the square root of -1. We know that I squared equals -1. We know that I cubed, which would be I times I times I, or the square root of -1 times the square root of -1 times the square root of -1, that's going to equal the negative square root of -1. And then lastly, we know that I to the 4th power is simply going to be equal to 1, because I'm going to have the square root of -1 multiplied times itself 4 times. The square roots will cancel off, leaving me with -1 times -1, which does in fact equal 1. So if we can remember these four, we know that I is equal to the square root of -1, I squared is equal to -1, I cubed is equal to the negative square root of -1, and I to the 4th is equal to 1. Every power of I beyond that will come back down to one of these four options, plus, let me just add in here, I to the 0, just like anything else to the 0 power, is equal to 1. Alright, so we've got I to the 0 is equal to 1, I is equal to the square root of -1, I squared equals -1, I cubed equals negative square root of -1, I to the 4th equals 1. Now let's just say, for example, we have something like I to the 12th. If I'm trying to figure out which one of these special categories that's going to fall under, what I'm going to do is take the exponent, and I'm going to take it and divide it by 4, which is the highest power that I have over here. When I do that, I'm going to get 3 with a remainder of 0. Normally I don't worry about the remainder, but in this case that's actually the only thing I care about. Because now what I'm going to do is take that I and raise it to the remainder that I got. So I to the 12th is equal to I to the 0 power, which is just 1. We could do the same thing if we have something like I to the 23rd. I'm going to take 23, I'm going to divide it by 4, and I'm going to get 5 with a remainder of 3. So I'm going to take I and raise it to the 3rd power. And we said just a minute ago that I to the 3rd power is equal to the negative square root of -1. Alright? So that is how we're going to handle all of the imaginary numbers and when they're raised to a certain power. Alright, so now let's simplify some complex numbers. We'll do 2 examples. Pretty straightforward. We'll do the complex number of 2 plus 5i, and we're going to add that to the complex number 3 plus 4i. Alright, so because this term is being added, I know that I don't really need the parentheses. That's the same thing as 2 plus 5i plus 3 plus 4i. Now I'm just going to combine my like terms just like I would any other time. I've got a 2 and a 3 that I can combine. 2 plus 3 is 5. Takes care of that and that. And then I've got 5i plus 4i is going to be 9i. So that's all we're going to do. On the second one, this is not going to be anything new, but we'll look at one just to refresh. We've got 7 plus 2i minus 10 plus 9i. Alright, so hopefully this guy sends all kinds of red flags to us. We know that we need to push that minus through, distribute it. There's an understood 1 here. So we need to distribute that through this quantity. So I'm going to get 7 plus 2i. And when I distribute that through, I'm going to get minus 10 minus 9i. Now I'm just going to combine my like terms. 7 minus 10 is negative 3. Takes care of that and that. 2i minus 9i is minus 7i. And that's as far as I can simplify that. Alright, so let's multiply a couple of these. Let's do a is going to be the square root of negative 12 times the square root of negative 18. Alright, so before I start trying to multiply them, I'm going to go ahead and simplify them. I know that the square root of negative 12 is the same thing as negative, let's call that negative 4 times 3. And this one is the same thing as negative 9 times 2. So I can pull this negative 4 out as a 2i, but that 3 stuck under there. So I'm going to get 2i square roots of 3 times, over here I know this negative 9 can come out as a 3i. So I get 3i, that 2 is stuck under there, square root of 2. Alright, so now I've got 2i times 3i is 6i squared. And 3 times 2 under the radical is going to become the square root of 6. But I need to recognize this guy. We said earlier that I squared is equal to negative 1. So I'm going to replace, I got 6, replace I with negative 1, square roots of 6. And I'm going to have negative 6 square roots of 6 as a solution to this one. Alright, let's get it a little bit deeper here. Let's do a complex number, 8 plus 7i times another complex number of 6 plus 2i. Alright, so I automatically see a binomial times a binomial. I need to be thinking FOIL. So when I multiply the first times the first, 8 times 6 is 48. And the outside times the outside, 8 times 2i is plus 16i. Inside times the inside, 7i times 6 is plus 42i. And then the last times the last, 7 times 2 is 14, and I times I is I squared. Again, I should immediately be recognizing that I've got an I squared there. So let's clean this up a little bit. I've got 48 plus 16i plus 42i is going to be 58i plus 14, and instead of I squared, I'm going to write negative 1, so I'm multiplying there. I'm going to get 48 plus 58i minus 14. Now I can combine like terms again. I'm going to be left with 34 plus 58i. Alright, nothing crazy. We just got to take our time, catch all those I squareds, and make sure we take care of them. Let's look at a division one. So I've got a complex number 4 plus 6i over 2. Alright? When it has a single term denominator, I can just break those apart. That's the same thing as 4 over 2 plus 6 over 2i. I could have put the I in the numerator. I can have it on the outside. Whichever way you like better is fine. This just, to me, shows it more in the complex form. So I know that 4 divided by 2 is 2, plus 6 divided by 2 is 3, and my I just hangs out with it. Alright, don't make these harder than they are just because they look different than what we're used to. We're handling pretty much the same. Just like if it was an x, you just have to know that once it gets above x or I to the first power, that it's going to change to either the square root of -1 or to -1 to +1. It's going to change to something. So we just got to remember that last step. Alright, so it's not a coincidence that we started learning about complex numbers right after we learn about factoring using the quadratic equation, or quadratic formula. So let's see how that works. If we have the equation of x squared minus 4x plus 8 equals 0. And it tells us to solve this quadratic equation. My first step generally is I want to see, can I do this by hand? Can I just do 2 factors set equal to 0? Let's see. I know my first terms have got to be x and x. I know that because this term is positive, that that both my signs are going to be the same, and they're going to be whatever this sign right here is. So I know it's going to be minus and minus, and then I need 2 numbers that multiply together to equal 8 and add together to equal -4. That's where the problem comes in. I can't think of any numbers that would make that work. Alright? So because 8 is the one that's messing us up, it's the one that I can't get 2 numbers that multiply to equal that, the factors of it that equal it, but add together to equal -4, so I'm going to get rid of it. I don't like that one over there. I'm moving it to the other side. Those will cancel, and I'm going to be left with x squared minus 4x, leave my little space where that was, equals -8. Alright, so we learned how to do this. It's completing the square. The trick here is I need to make a new constant term that I know will work. And I know it'll work if I do it this way. I'm going to take the b term. So we're going to take the b term and we're going to take half of it. So you got to remember when we complete the square, you got to think 1/2 of whatever b is. In this case, it's 4. And we're going to take that whole thing and square it. When I take half of it, I know that when I add it to itself, it's going to come back to the 4. And by squaring it, I know that the factors are going to multiply together to equal my last one. So half of 4 is 2 squared, which is 4. So I'm going to add 4 to this side, which means I have to add 4 to this side. Now, because I completed the square, I know it's going to be a quantity squared. -8 plus 4 is -4. I know it's going to be x minus, because of the minus there, and it's going to be whenever half of b was, so it's going to be a 2. When I multiply that out, 2 times 2 is 4, 2 plus 2 is 4, so it works. This is why we're learning about this lesson now. Previously, if you would have had a negative on this side, you probably would have said there's no solution. But now we know that we can take the square root of both sides, which we call this extracting the square. When we take the square root of both sides, we know that we're going to be left over here with x minus 2. And over here, we're going to be left with plus or minus the square root of -4. That's going to simplify to x minus 2 equals plus or minus the square root of -4. Well, the 4 comes out as a 2. The negative comes out as an I, so I'm going to get plus or minus 2i. Add 2 to both sides. And I'm going to get x equals 2 plus or minus 2i. Alright? And that's going to be my solution. Alright, so we solved that one by completing the square. Let's do one using the quadratic formula. I've got 6v squared minus 12v plus 12 equals 0. I know the quadratic formula is going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. And I know that a is equal to 6, b is equal to negative 12, and c is equal to positive 12. Plug those into my formula, I'm going to get negative, well, b is negative 12 plus or minus the square root of negative 12 squared minus 4 times a is 6, c is 12, all over 2 times a, which is 6. So I get minus negative 12 is going to be just 12, plus or minus the square root. Negative 12 squared is 144. 4 times 6 is 24. 24 times 12 is 288. Double check that in your calculator. All over 2 times 6 is 12. So I'm going to get 12 plus or minus the square root of 144 minus 128 is minus 144. All over 12. Alright, so that's going to be 12 plus or minus the square root of negative 144 is going to be 12i over 12. And I know that all three of those terms have something in common. 12 divided by 12 is 1, plus or minus 12 divided by 12 is 1, so 1 plus or minus I. Alright, so we could have completed the square on either one of them. We can do quadratic formula, but both of them are going to get us to the same thing, and it begins to show why we're learning about complex numbers, because we're going to have these radicals that could potentially have negatives underneath them. That is pretty much it. You're just going to have to get some practice on them. Do the homework, work them a couple times, get familiar with them. They're not that bad. You just got to memorize those values. So you got I is equal to I squared is equal to negative 1. Well, I is equal to the square root of negative 1. I squared is equal to the negative, or square root of negative 1 squared, which is negative 1. I cubed is going to end up being equal to negative I. I to the fourth is equal to 1. We talked about it at the beginning. That's the main thing you got to memorize, and these won't be too bad.